All right, so this is page 131 from our booklet, Original Value Problems. So the reason this is called original value is because we're actually going to be working backwards from what we had been doing with the simple interest problems, or kind of like those percent increase or percent decrease problems. We'll be working backwards. We'll be given kind of like the end result or the answer, and we'll be asked to find the original amount that they're talking about. So let's read through this to kind of show you what I mean. It says a shop has 25% off its prices in a sale. Okay, so if I'm going from the original amount and then there's a sale and there's a 25% off, that means that it's a 25% decrease. So we're talking about a percent decrease here from the original to the new. So we're going from the original, we're doing a percent decrease, and then we'll come up with the end result. All right, so we're talking about percent decrease. A sale means something is becoming smaller, which means the price is decreasing. So that's why we say decrease. It says below, here are the sale prices of some of the items. They're showing us the results. So all of these represent the end result. That's what sale price means. They want us to find the original amount. So we're looking for the original. All right, so let's think about what we normally would have done, right? We normally would have taken the original, applied some percent decrease by timesing by some value, right? And then we would have found our end result. If I'm going backwards, right? Backwards means opposite. So if I'm given the end result and I want to apply that percent decrease in order to find the original, see how I just went backwards? From here, I'm going in the opposite direction, applying that percent decrease. Instead of multiplying like I did here, like we've done so far, today we will be dividing by that percent decrease amount. And remember, to find that percent decrease amount, we find the multiplier. So this multiplier will be the same in every single question for question 1. If it's a 25% decrease, 25% decrease, remember, to find the multiplier, we are decreasing by 25%. So we start off with 100%, take away 25%. As a percent, that would give us 75%. We convert to decimal, so 75 divided by 100 is 0.75, and that is our multiplier that we're using, okay? So normally, if I had the original amount, to find the result, I would just multiply by 0.75 to get my answer. But today, since I'm given the result and I'm trying to find the original, we'll divide. So basically, to find the answer for each of these, we just need to divide by that multiplier value that I came up with, okay? So it's kind of like the opposite. It's kind of almost exactly the same steps that we wrote down the other day, where we found the multiplier, and then step 3 was to times by the original amount. We'll do the same exact step 1 and step 2, but step 3 is, instead of multiplying, we'll divide, okay? So I'll do the first one with you, and then I'll take a look at question 2. This would be 3.6 in the calculator divided by 0.75, and our answer is 4 pounds and 80p. Okay, let's talk about, or let's compare our end result to our original. Okay, this is the original, and this is the end result. Notice the original is larger than, sorry, what did I just say? Sorry, yeah, this is the original, right? We found the original. Notice the original is larger than the end result, which we were given. That's because this was the original price of the item, and then this is the sale price. And we would expect the sale price to be less, right? Imagine you're going to the store and they said, okay, these apples, a bundle was originally 4 pounds and 80p, but now they're 3 pounds and 60p. That's kind of what's happening here. There was a 25% off sale, and so this is the price of 25% off the original cost of the apples. Okay, you wouldn't expect the new price to be larger because it's on sale, which means that it's less. Okay, hopefully that's starting to click. All right, let's look at question 2. I'll work question 2A and then I'll let you try the rest of the worksheet on your own, okay? So remember, we want to find the multiplier. That's kind of the first thing we want to do. This question is almost exactly the same as question 1, except we have 25% off its prices. We're given the sale prices again. They want us to find the original price. So to find the multiplier, again, 25% off sale means that a percent decrease happened. So to find the multiplier, I need to take 100% and minus 20%, which gives me 80%. All right, step 2 was to convert to a decimal. So I will divide by 100, all right, which gives me 0.8. I'm just gonna leave it like that, 0.8. Okay, remember step 3 today, instead of multiplying as we did before, today we will be dividing by that percentage or by that decimal that we came up with. Okay, so that multiplier value is 0.8. So I'm going to take each of my values and divide by 0.8. Okay, you'll do this for every single problem on this list. So I have 4 pounds divided by 0.8, and that would give me 5. So again, let's talk about what this means. I'll write the decimal out, 5 pounds. This means that the original price of the item was 5 pounds. They said there's 20% off, so the new cost of the item is 4 pounds. All right, so you would apply that same method, 0.8, just divide all of these values by 0.8, and you should get your original answers because they all have the same sale of 20% off. In question 3, I'm going to ask you to set that one up on your own, so I want you to try your best. But just to kind of give you a tip, right? All of these items have 15% off. So once you find your multiplier, you just take that value and divide every single number that you're given by that multiplier. Okay, so it's always the same in each question. All right, keep up the hard work. Email me your questions and have a great rest of your day. Thanks, bye.